Hello everyone. This is Gayatri Priya, Assistant Professor in the Department of EC of RMD Engineering College. In today's session, we are just going to have a discussion on memory code. That too, we are just going to discuss about the read-only memory. Right. While designing the large memories, we will be thinking about the size of the memories. So how should be the memories? It should be as small as possible. So, since the size of the memory cell is small, in no way it should affect the speed and the reliability. Even though the memory cell size is taken very small, I should achieve a maximum speed and reliability. Here we are having various types of memory code: read only memory, non volatile, read write memory codes. In today's session, we are just going to concentrate only on the read only memory. Right. So, what is this read only memory? So, this is going to be a non volatile memory. So, what is the meaning of non volatile memory in the sense? Even though the power goes off, the data will remain there. That is, the data will be stored permanently even though the power is switched off. Okay, that is your read only memory, non volatile memory. So it is used to store the program for the processor for with a fixed application. For example, we can take a washing machine, calculator, and gaming machines, everything and all. We'll be having this read only memory alone. What is the basic disadvantage of this diode cell in the sense? Here we don't have any isolation between the bit line and the word line, right? We don't have any isolation. We could not make a categorization of this bit line and the word line. So how to overcome this? Right? So in order to overcome, we are just going to make use of the gate source connection. In between, we are going to have a diode. The gate source connection of a NMOS transistor is going to be replaced by the diode. Okay, so those implementations are being shown here. So we are having various approaches in order to implement one and zeros in the read only memories. Let us look at the one. This is for diode read only memory. So in this diagram you could see the vertical line indicates bit line and the horizontal line indicates the word line. BL stands for bit line and WL stands for word line, right? If a diode is connected in between this word line and bit line, then that is 1, state 1 in your diode ROM. If nothing is connected in between your width line and your bit line, then that is called state 0 in diode ROM. Coming to mass ROM 1. Here in the place of diode, I can just have an NMOS transistor. You could see the gate is connected at the word line, right? And here you could see the source is connected to the supply VDD and the drain is connected to the bit line. This is state 1 for mass ROM 1. Here also, if nothing is connected, that is for your mass ROM 1. Similarly, coming to the mass ROM 2, if nothing, just make the vice versa of this category. If nothing is connected between your word line and bit line, then that stands for state 1 of mass ROM 2. Similarly, if we connect a NMOS transistor whose gate is present at the word line and the source is connected to the bit line and the drain is grounded, then that is state 0 in your mass ROM 2. You can correlate these two. Here, the source is connected to VDD and the drain is connected to bit line. Whereas here, the source is connected to bit line and the drain is connected to ground. This stands for 0 in your mass ROM 2 and this is the 1 in your mass ROM 1. Right? Let us take a 4 cross 4 OR operation. Okay, how our implementations can be done? So if I am having a 4 cross 4, I have to draw 4 vertical bit line, similarly 4 horizontal word line, WL of 0 to WL of 3. Similarly, this is BL of 0 to BL of 3. And moreover, we need a bias voltage in order to operate the transistor, right? All the gates are being given the bias voltage, and all the drains are being grounded, and each bit line is connected to the source of the transistor that is made for as the pull down load, right? So for example, if you are taking here in the sense, here the word is 0, okay, and the source is connected to the bit line, and this part is being grounded, therefore obviously this is 0. And before getting into this, you could see a VDD line is drawn in between WL of 0 and WL of 1, and similarly between WL of 2 and WL of 3, right? Similarly, coming to this point, okay, here the source is being connected to supply, right? And the drain is connected to the bit line. Source is connected to the supply, and the drain is connected to the bit line. Therefore, this is going to be your data 1. In case of your MOS ROM 1, this is going to be your data 1. Okay, so here in this bit, I'm going to have the data as 1. Okay, right. And coming to the next thing, here we are having the source is connected to bit line, right? Whereas here it is being connected to the supply. Similarly, you could see here the source is connected to the supply, and the bit line is connected to the drain. This bit line is connected to the drain, and this is connected to this source. Likewise, you can implement whatever OR operation, an OR operation, and now any gate operations can be implemented. If it is a 8 cross 8, I will be having 8 number of vertical lines and 8 number of horizontal lines in order to implement the ROM cell array. Hope you understand this sessions. Thanks a lot.